Everyone, here's a quick review of how to write recursive rules, explicit rules, and kind of work off of each other's formula. So we're writing recursive rules. We're given an explicit formula. This is an arithmetic explicit. I know this because I have my common difference times n plus f of 0. So I want to write my recursive rule and do f of n equals f of n minus 1 plus the common difference where n is greater than 1 and f of 1 equals k. So that should be the formula we're working towards in the arithmetic ones. So for this one, let's break out what we know. We have d is 4. We have f of 0 is 3 if we look at our formula. So now all we need to do is plug it into this. In our recursive formula, we know that this and this would remain the same. It's the common difference we need to change. So we have f of n equals f of n minus 1 plus 4, our common difference. So we're going to keep n greater than 1 and say that f of 1 equals, well, f of 0 is 3, and our common difference is 4, so we take 3 and add 4 to it to get our next term, and that's 7. So that's how we write a recursive formula from this. All we're doing is plugging our common difference and using our common difference and initial term to get to our f of 1 term. So problem 2 is an explicit geometric. So we need to turn this into recursive. The difference between this and that is, instead of plus d, it would be times r. So f of n equals r times f of n minus 1. And then the rest, the n greater than 1, f of 1 equals k remains the same. So here, r equals 6, so the number inside the parentheses being brought to the power. And f of 0 equals 2. So we keep the f of n the same. F of, and r first. With the f of n minus 1, that always stays the same. All we sub in is our r, our common ratio, which is 6. So that's our recursive formula so far, when we say n greater than 1, and f of 1 equaling, well, our initial term times our common ratio is 2 times 6 is 12. So that's our first term. We know we're multiplying them because it's geometric and we have a common ratio. Alright, so let's move on to the explicit rules. Here we're given recursive rules. We're saying that we have f of n equals f of n minus 1 minus 3, n greater than 1, f of 1 is 6. To write an explicit rule, we need all our information. So we know that the common difference is negative 3. We know that f of 1 is 6. So that helps us in some ways. So we want to construct this. F of n equals, always going to be f of n. We want to say the common difference times the number of terms, so negative 3 times n. And it's always good to put the negative ones into parentheses just because sometimes things will get messed up. And we want to find our f of 0. So f of 1 is 6, and we know we're subtracting 3 each time. So if we had term number 0, 1, 2, 3. Term number 1 is 6. Term number 2, if we're subtracting 3, is 3. Term 3 is 0. So if we went backwards to find what number we'd subtract 3 from to get to 6, it's got to be 9. So we'd say plus 9. Let's try number 2 with a geometric, since we're multiplying in our recursive formula. So here we can pull out that r is 7. Right? Since there's no addition, if you see addition, you know arithmetic. If it's no addition in the problem, it's definitely a geometric. Even in the explicit, there's addition, and here would be the negative addition of 3. So r is 7, and f of 1 is 21. So let's put this into our formula. F of n, because we always have f of n, equals f of 0 times r to the n power. Well, we know what r is. We know r is 7. That always goes in parentheses, put to the n power. F of 1 is 21, and we're going up by multiples of 7. So if term 1 is 21, what number multiplied by 7 will give us 21? 3. So that's our f of 0 term. So we have 3 times 0 to the n power. Basically, to work backwards, you have to figure out either what number multiplied by 7 will give you 21, or you could just divide 21 by 7 to use the inverse operation to give you 3. Just like in this one, instead of subtracting 3, we added 3, the inverse operation. Alright, so if I give you just a sequence, and I ask you to write the explicit and recursive rules, this should be the easiest because all the information's here. You can see on this one that you're adding 4 each time. You can see your f of 0, you can see your f of 1, so it should be pretty easy to write the rules. Explicit, you would say f of n equals, and since you're adding, it's arithmetic, 4 times n plus 3. For the recursive, f of n equals f of n minus 1 plus 7, plus 4, where n is greater than 1 and f of 1 equals 7. All we're doing here is plugging in the common difference and our first term. In the first one, all we do is plug in our common difference and our initial term, our f of 0. So on to the next one. 4, 16, 64, 256. Looks like we're multiplying by 4 each time. So we would see that this is a geometric. We would say for our explicit, f of n equals our initial term 4 times our common ratio 4 to the n power. Our recursive, f of n equals our common ratio times f of n minus 1, where n is greater than 1, and f of 1 is 16. That's our 0th term, that's our first term. So hopefully that helped out.